Okay, welcome back. Let's continue our talk about graphing equations of lines and linear functions. Sometimes equations of lines are not given in nice, neat packages as they usually are when it comes to equations. When it comes to some of these equations, sometimes we have to come up with our own function. Right now, this is not in functional form, but to write it in function form, in order to write the equation of anything in function form, we have to isolate y in our equation. So the first task for us, let me get a line here, is to isolate y. Using a little bit of algebra here, let's see. If we isolate y, here's the way I think about this. I would add negative 5x to both sides of my equation equally. Of course, the reason being that on the left, if we add negative 5x to positive 5x, we're going to get a 0. And if we add negative 5x to 10, we're going to get, make that a little bit better here, we're going to get something that looks a little bit closer to the kind of equation that we want. All right, so we get rid of the x terms on the left. We're left with negative 2y. Of course, the next step would be to divide everything on both sides of the equation by negative 2. So we divide by negative 2, divide by negative 2, divide by negative 2. We're going to get y is equal to, let's see, negative 5 divided by negative 2 is positive 5 over 2 times x minus positive 10 over negative 2, 5. Okay, so this graph is going to be written in function form. F of x would be equal to 5 halves x minus 5. So this is what we mean by rewriting this in function form. So when you see those instructions, that's what you're going to want to do. Okay, so how does this look? Well, of course, we would want to choose some points that is going to help us out right here. Some of those basic points right here, since the denominator is equal to 2, is to choose points that are multiples of 2. So let's just choose a couple just for the sake of checking it out here. Let's say negative 2, of course, seems like a pretty good idea. And at x equals negative 2, we're going to get a function 5 halves times negative 2 minus 5 is going to give us 5. The 2's cancel. It's negative 1. Negative 5 minus 5. So we would get negative 10. Okay. If we chose f of negative, if we choose f of 0, we should always choose 0, right? That's an easy one. That means 5 halves times 0 minus 5. We like that because we just get negative 5. So that's pretty good. Okay, how about f of positive 2? Well, it's going to look kind of like our calculation above, where we took 5 halves. This time we multiply it by positive 2. Pardon me, let's take positive 2. We'll just make it a positive there. Come on, pen. There we go. Minus 5. My pen just does not like me today. Let's try that again. Minus 5. There we go. That's a better minus 5. The 2's cancel. We're left with 5 times 1 minus 5. Well, guess what? We end up with 0 right there. So what are the coordinate points that we're going to get right here? Looks like we've got negative 210. We've got uh, we've got 0, negative 5, and we've got 2, 0. All right, so now let's go ahead and let's check this out right here. If we graph this thing, what's it going to look like? Well, let's see if we can get this to cooperate with us just a little bit better here than it is. There we go. Let's take that. Now, come on now. Come on, graph. Here we go. I'm going to grab that little blue box because sometimes it's supposed to do a thing like actually graph this for us. There it is. There's our graph, right? Let me take this, shift this around so we see those points a little bit better. All right, that's what our graph looks like. Happy graphing.